Thanks so much.
Thank you, Gordon. It's a pleasure to be back here at the P4 conference. Today I want to describe a trial that AT&T did with white boxes in P4 in a coast-to-coast network carrying live production trial. Before I get into the details, I would like to motivate why we're doing this, because that'll be an important thread throughout the presentation. And let's just do a review of the evolution of networking from a carrier's perspective. So a number of years ago, call it 20, 30 years ago, networks were mostly built by single vendors of a particular function. One vendor would be picked for a particular function. They would generally be end-to-end in that, in providing those boxes and functions. Then about a decade ago, there was a significant shift to multi-vendor networks. So we would have not just one supplier, but multiple suppliers providing a service function. And this was the era where we pushed open standards. And that's what made this successful, so that one supplier's box could interoperate with another supplier's box. Over the past 4 or 5 years now, we've been moving to what we call Network 2.0. This is where we further disaggregate these functions into multiple functions. So this is where we're, instead of taking a vertically integrated system, we're separating hardware and software, applying virtual network functions, applying merchant silicon in new combinations. And this drives a lot of new piece parts to manage, a lot more things that a network engineer has to worry about and integrate. And then now we're moving, once you have all these piece parts, each of these piece parts provides information to help manage the network. And this is what we call Network 3.0, where you use the power of all the information of all these elements to provide new services, new capabilities, new ways to manage the network. What's the extent that we're doing this? So AT&T has its AT&T Integrated Cloud. Think of this as various size data centers. This has the traditional elements, top-of-rack switches, cloths, leaf spine, networking, servers, storage, et.cetera. At each of these locations. We've been building this globally. We've been building it on open source software, and for this particular audience, where we're applying P4 and focused on doing that is where we have pipelines from merchant silicon ASICs as well as x86, providing virtual network functions. And so we have global extent. So then the other motivation is why we're moving in this direction is the tremendous growth of traffic. Since the iPhone was introduced in 2007, in our network we've seen tremendous growth, 250,000% in the mobility traffic. And likewise, to accommodate that type of growth and have an appropriate scale-out strategy to achieve this growth, we've been focused on converting most of our network functions to virtual network functions. And so a couple years ago, 3 years ago, we set a goal to try to virtualize 5% of our network functions. We achieved a little ahead of that. Last year, our goal was 30%. We ended the year with 34% of network functions moving towards virtualization. And this year, we set a goal for 55%. And we view this as a tipping point year because once you go past the 50% point, that's the new normal, right? That's the new normal of running these networks. And so in this case, we're really motivated to handle this scale, handle these new network functions in a new way, and which is driving us to new designs, new solutions, and based on white boxes. So how do we manage all these piece parts? There's so many different piece parts that now come into that have to be managed with disaggregation. The only way we can survive that is through automation. So AT&T a year ago went to the industry and said, we've created this platform called eComp, inquired from the industry whether this could be useful across to other carriers. The answer came back with a resounding yes, and earlier this year we renamed it to OwnApp, this open networking automation platform. This is the keystone that's going to help us automate all these different disaggregated piece parts. And we open source more than 4 million lines of code back to the industry for this platform earlier this year. And the response with the carriers has been very positive. So far, 38% of the global wireless providers have signed up, and so this amounts to more than 1 billion wireless subscribers that will be managed, the automation through OwnApp over time. And we're anticipating another 34% of the carriers signing up soon. So with this background of what we're trying to do, this disaggregation and this automation, we chose to challenge ourselves to say, hey, can we pull all the piece parts together in a end-to-end network? And so we didn't do this in isolation. We worked with, in addition to the OwnApp code that AT&T provided, we had partnerships with merchant silicon suppliers, Barefoot, Broadcom, Intel. We had an open network OS from SnapRoute and an open compute platforms from Agema and EdgeCore. And through this collaboration, let me start diving into a bit of the details of what we pulled off. And so in this network, we chose to do live production traffic of a very common use case in carrier networks. So at the edge of each of these networks in San Francisco, Washington, DC, traffic comes into our network aggregated with multiple customers, multiple services into our network. And this is a standard configuration where carriers interconnect networks to other carriers' networks, providing access or even our own network. The first box that this aggregated Ethernet traffic hits, we call this function internally an Ethernet gateway. The purpose of that box is to separate out the aggregated traffic and send it to the right edge platform to do the processing, whether it's a voice or if it's data, broadband, a VPN service as an example. It has to get separated out. And so the first boxes on either end were based on the Tofina P4 switch, and it was providing a switching function to take the VLANs in, do the appropriate mapping, get telemetry on the packets, and then pass it on to PE boxes. And so in this case, this was a layer 2 function mapping VLANs into MPLS for transport from across the country. So there was 2 PE boxes, and we bookended it with these Ethernet gateway switches. And so let's dive in a little bit more. Well, and then one more part that not to be missed is one of the key things was this in-band network telemetry up into the OwnApp system. And this is part of our evolution of our network to use this new information in new ways to provide much greater degrees of automation than has been possible in the past. So let's drill down into this a little bit more. And so OwnApp is a very sophisticated platform. I won't go into the details. This is a very dense diagram. You can go to OwnApp.org and you can read up on tutorials that describe the entire system. It describes every subcomponent system, and you can do that as an exercise. So one of the things we tried to really worry about is at the edge of the network, that's the natural place where you'd want to get packet by packet telemetry. So you could have a very good view of the customer's packet flows, their services, and so what we ended up doing is building a connectivity through this P4 switch with INT, taking that telemetry up into our OwnApp system. And in addition, we, to get this packet by packet granularity on things like latency, jitter, as well as microburst, all sorts of parameters. In addition to that, we built our own AT&T Analytics app that ran on the white box in a container. And this particular application that we built and put on the box and ran was focused on creating a health index of the packet flows coming into that box. So at the very edge of our network, we could determine the health at ingress and egress of the network of individual packet flows. And this app streamed the appropriate information in conjunction back up to OwnApp into this particular submodule of OwnApp, this data collection analytics events, so that these two could work in conjunction. And where we're heading with this is to institute new ways to do closed loop control. So you can get input from the network, aggregated input, make decisions, dynamically change the network based on that information. So let's look at the ingredients, and you'll see a theme here very quickly when I start running down the ingredients. So we had 4 open compute white boxes, 4 different merchant silicon chips, an open source network operating system, Open Linux and Ubuntu, open source deployment and runtime mechanisms like Docker, open source analytics stack, open source dashboard, open source language. You see the theme? Open all the way down from top to bottom. And in addition, we wrote our own software, bootstrap software to take all these piece parts and efficiently bootstrap the box in production when a technician first turns it on in the field, in our central offices, as well as the analytic apps. Someone will probably ask the question, do we plan to try to open source the analytic app? Yes, we're trying to work through that process right now internally to release that back. And not to be overlooked is one very highly motivated cross-functional team within AT&T, as well as with our external collaborators that I mentioned earlier. And so we did this to increase the speed of innovation in our network. So how long did this take? It took from, we started this the first week of January, we were live in production the end of March. So we did all this in about 3 months. And what we ended up with is a coast-to-coast network that exercised processes throughout AT&T because you don't deploy something into a central office without formal processes to make sure you don't do harm to other traffic. So at all levels, people had to be engaged, a large team. We had a common network OS. We had new packet-by-packet telemetry that we've never been able to have before, multiple merchant silicon suppliers, WAN carrier features like MPLS on a merchant silicon box, as well as P4 in production. And so as we started to think about this, we started to think about how do we look at a white box in its architecture and where do we want to head with it. And so in this particular diagram, this to the left is an overall abstraction of a white box with the gray parts being the hardware components of it, the CPUs, the merchant silicon ASICs. The portion in the dashed line is the network OSs. And in particular, we were very pleased with the results of being able to add our own software. So these are the orange and green components where taking our own software, adding it to the box, and doing value-added functions, or having other third parties work in this ecosystem to provide software into this box. And so with this disaggregated hardware and software, we're really trying to allow the introduction of new vendors to the ecosystem so that a small company with a new idea, if they work within this ecosystem, they may come with some subcomponents. It's very clever, very interesting to us, and be able to fit into this open ecosystem, something that would not have been possible unless this was an open ecosystem. And then as we moved down this stack, we started thinking very carefully about, okay, how do we manage this entire ecosystem from OwnApp at the top all the way down to the merchant silicon ASIC. And we started thinking about areas where additional work needs to be done. And so these are the numbered interfaces on the appropriate abstractions into the ASIC SDK, the hardware abstraction layer, into the various control functions, whether it's provided by a network operating system supplier or whether we put those functions in ourselves, all the way up to OwnApp. And I was very excited to see the evolution of the P4 language this morning with this new extern construct, because I think that'll help with a lot of these items that we've been thinking about, denoted as 1 and 2 on this diagram. It'll certainly expand the capability and flexibility. So let's talk about some of the learnings here a little bit. One of the things is, and since I'm a carrier and I want to talk about not just technology, there was a really big people learning. There was a disruptive but very healthy collaboration model between many suppliers, many new entrants in pulling this off. And in addition, there was a skills pivot. AT&T's had a program for a number of years now to retrain the 250,000 employees that are part of AT&T to understand this new technology, to be able to embrace it. And if we hadn't had that training, it would have been very difficult even just to have a common language to deploy this box in a central office with a technician on site. And so if you want to read more about that, Harvard Business Review did an overview of our skills pivot or retraining program to adopt the new virtualized technologies. And so what's the future work there? Certainly continue to foster and generate the culture of moving to open source. And then it's really this continuous learning. The technology is moving so fast that technical people manage the network have to just learn continuously. So then another thing we were very pleased to discover is the ecosystem. We believe that the ecosystem has reached critical mass from OwnApp with open source components all the way down to the merchant silicon. Something that did not exist probably a year ago, to have all those components from top to bottom from a carrier's perspective to be able to be in place to pull this off. And really the speed was enabled by this being an open ecosystem. If piece parts were closed, we couldn't have done this in 3 months. Is it completely done? No, there's more work to be done. There's incremental features that will be needed at various levels of these ingredients that I mentioned, as well as basically providing additional features that bridge our brownfield network to our greenfield networks. It's a little easier to do a new technology in the greenfield, but to be successful, it needs to interoperate with the brownfield, so there's more work to be done there as well. So with that, thank you very much, and I think we have a couple minutes for some questions.
So there's sort of a kind of growing realization that that the sort of network function virtualization strategy of turning kind of physical middle boxes into virtual middle boxes doesn't really lead to an optimal or efficient solution. And with something like P4, data plane functions can now be implemented in switches in a much more sort of both power efficient and sort of faster, higher performance way. And so my question for you is AT&T thinking of sort of moving many of these sort of virtual network functions, sort of splitting them up into control and management functions, which would be in like an SDN controller and orchestration framework, and actually moving the data plane functionality into something like P4?
Yeah, and that's an excellent question. So we don't view it as an either-or question, right? There's network function virtualizations, and then there's packet pipelines and merchant silicon. We view it as a continuum. We discuss internally what we call a zone of advantage, where is a network function provide an advantage and works appropriately with the right economics versus a packet pipeline. And we view it as this continuum, and we try to design systems that allow us to transition between the two as the technology evolves. So we're not going to put it in one place. You know, it could evolve over to P4 and an ASIC, or it may evolve to a network function. We try to make sure we're flexible enough that we can do either.
First, kudos on the aggressive retraining program. That sounds awesome. I don't know if you can speak to this, or if you already mentioned, were you carrying subscriber traffic on this experiment, or this deployment?
Yes, this was aggregated traffic that carried multiple flavors of our traffic, from voice, mobility, VPN traffic, internet traffic that was aggregated on this demo.
We have time for one more. So, pertinent to the topic for today with P4, is it your general plan to publish and make available the P4 programs that you use and deploy? Is it the plan to make that open source as well? And sort of related to that, I know you've talked in the past about using your own P4 programs as a way of specifying behavior that you would like to see beyond just, as an input to a compiler, as a way of just unambiguously specifying behavior. I'm just interested in how your thoughts have evolved.
Yeah, we definitely still want to use it as a specification that's unambiguous. We do want to release the code where it makes sense to release the code, especially for common functions that there's no secret sauce associated with it. And that is still our goal. With this trial, I think there's going to be a lot more energy behind this to get these things completed and released out to the broader community where it makes sense.
Okay, we'll stop there and move on to the next talk. Thanks again, Claire.
Thank you.